My name is Kainton, the tech and today I'm going to explain to you how k-means clustering works. So this will be for you to understand the concept and be able to explain it using the minimal notations and diagrams. So basically, k-means clustering seeks to partition the set of observation into k non-overlapping clusters. Okay. So what I'm going to do, I'm going to first draw up a diagram. And then I'll use this diagram to be able to explain k-means clustering to you. So let's start by drawing. I'm going to take a pen. Take a pen. Okay, so let's say we have a data set in this way. So we have this place, this place, this place. Okay, so I'm trying to kind of choose the data point so that I may have something like maybe 3 clusters. So now I'm going to now map them out. So let's say we have this first cluster, and then the second cluster should be this, and then finally one thing you need to remember is the clusters should actually not overlap. So I'm going to try to draw this in this way. All right, so we have 3 clusters. In this case, k is equal to 3. There are 2 things you'll need to know, the 2 conditions for k-means clustering, and these 2 conditions are very important. So if you have, for k clusters, and we have that these clusters are C1, C2, all the way to Ck, the all-inclusive condition, that is the all-inclusive condition, is the first condition that has to be met, and the all-inclusive condition simply means that C1 union C2 all the way to union Ck is equal to 1, 2, all the way to n. That is, it means that all the observations should be included in the data in the clusters. So there will be nothing like any observation that is left out. This is the all-inclusive condition. You should be able to understand it. Then we also have the non-overlapping condition that says Ci intersection Cj is equal to an empty set. So what it means is that we don't have any intersections. So there is nothing like this in clustering. There is nothing like this in clustering. All right. So k-means clustering, the first step is to choose k. Choose k. Okay. So the next thing we want to do is we want to define a variable r. This r is going to be equal to 1 if the data points belong to cluster k. So it's going to, for any data point xn, so xn will belong to cluster A. If sn belongs to k, then rnk is equal to 1. Okay. Otherwise, rnk is equal to 0. So how we write it is rnk is either 1 or 0. Okay. So if rnk is 1, if actually rnk is equal to 1, then rnj is equal to 0. So what it means is that once the data point k xn belongs to a cluster k, then that data point cannot belong to for any other cluster in the data in the space, then it cannot belong to those other clusters. So it's going to be 0 for cluster J once it is 1 for cluster K. All right, so there is something called distortion measure. Ordinarily, I'm going to write it that is something called WCK. So this is the within cluster distance. So what we are talking about is for each cluster, I also forgot to mention that you have this called a centroid. Each cluster's centroid. Okay, so each cluster's centroid is mu k, meaning that if we have a centroid, let me just use right. So let's say we have a centroid here, then we can actually measure distance from the centroid. So this centroid is given by this for this cluster. So we actually can measure the distance from here, from the centroid to this place, and that is going to be xn minus mu k, right? So this distance is what we are trying to minimize. We are trying to minimize this distance for all the clusters. So if we sum up this distance for all the data points within this cluster, what we are going to have is sigma. We are going to have xn minus mu k. In this case, we are going to have it that n is equal to 1 to the total number of items in there. But we are not going to do this. We are going to actually sum it for the three clusters. In that way, we are going to have, let me just say we assign j is equal to, this time we are summing from n is equal to 1 to n for all the data points. Then we are summing for all the clusters. K is equal to 1 to k for all the clusters, Rnk. So it's going to be, when we are summing for a particular cluster, it's going to be 1. For others, it's going to be 0. And we are going to take the absolute distance between the centroid and the clusters, and that will give us something like xn minus the centroid squared. So once you come up to this point, of course, this is about the same thing with this. So this is what I'm trying to break down. This formula here is what I'm trying to break down. Okay, so this formula has a name, or this function has a name. Is called the distortion measure. All right, so the goal of k-means clustering is to minimize this function. That is the goal of k-means clustering. So if you can't remember how to write this function, then remember how to write this one. This is a simpler one. So we are simply trying to minimize within cluster distance given by WC of k for all the clusters. K is equal to 1 to k. So it's about the same thing. Is equal to. So either of the two you can remember and be able to write it. You'll be able to explain clearly what k-means clustering is all about. And also remember these two conditions. This condition, all-inclusive condition, and also the non-overlapping condition. Those are the two conditions for k-means clustering. Now I'm going to actually stop here for now, and I'm going to thank you for viewing. Remember to subscribe to my channel by clicking on the subscribe button below this video. And that way you kind of motivate me to keep making these lessons. And also if you have some challenges, let me know. I'm going to respond to you and give you the necessary support you need.